All right, could you state your name and your position here at South?
I'm Rob Cloutier. I'm a professor of system engineering, and I'm the program chair for the system engineering doctoral program.
So under that, what classes do you teach or have you taught here?
I actually cover the extremes. I have EG 101, which is freshman introduction to engineering, and I teach the system engineering courses, fundamental system engineering, system architecture and design, systems thinking, and I've been a guest speaker at other courses as requested.
What level are those systems engineering courses?
Those are they're 600 level,
Okay.
so they're master/doctoral courses.
Okay. How did because I know your story is interesting. How did you get involved in civil engineering? How do you think you got to where you're teaching systems engineering?
I started as a system engineer in industry
Okay.
and spent 25 years designing, helping design ships and aircraft for defense contractors. Civil engineering goes all the way back to my stepdad, who was a civil engineer. So I did a lot of laboring on job sites, and you just don't live with someone that's a civil engineer without learning to fix things around the house and tear down walls and put them back up. In systems engineering, there's a notion of systems patterns, and in fact I did my doctoral thesis on patterns. My inspiration for systems patterns goes back to civil engineering, and a civil engineer and now professor at Berkeley, Christopher Alexander, who started writing about patterns as early as the 60s and has written thousands of pages about patterns for civil architecture that I've extended to patterns for systems architecture. So civil has wove in and out of my life for many years.
And for someone that doesn't know what systems engineering is there a succinct definition?
There is not,
Okay.
because system engineering is very broad. But generally speaking, system engineering is the discipline and practice of looking holistically at things that are engineered. And instead of concentrating on the mechanical aspect or the electrical aspect or the human factors aspect, they take a step back and look at the system as a whole. So if I put that in the context of civil, instead of looking at the plumbing and the electrical and the girders and the grading of the ground, it's taking a step back and looking at the building as a whole and how it interfaces with all of its stakeholders, how it meets the needs of the stakeholders, which could be city government, could be the inhabitants of the building, it could be the city itself, it could be the environment, it could be a lot of things. So how does that system and its subsystems, its parts, interact with each other and with the broader community?
How does one become a systems engineer?
That's a real interesting question, because there are a lot of people. The Professional Society for System Engineering is called INCOSE, International Council on System Engineers. And about half of those folks believe that you start out in another engineering discipline. And once you've mastered that discipline, if you're one of those people that start poking your head above ground level and looking around to understand how your discipline interacts with other disciplines, if you don't get your head whacked back down like a whack-a-mole, and you start asking questions, you start becoming a system engineer by understanding how your part of the system interacts with others. So there are very few undergraduate system engineering programs for that reason. The belief is that you really need to have 4, 5, 6 years of engineering practice before you start understanding how your discipline interacts with others. Typically at that point, then you will start working in systems engineering. You may go get a master's degree. There's a number of master's programs and doctoral programs in system engineering. much like the system engineering program we have here at South.
And so your father was civil. What is your engineering background?
I've actually been a system engineer from the beginning. I went to a university, went to the Naval Academy, which had a system engineering program. So though I did not graduate as a system engineer, I took a lot of system engineering courses. I actually have another very strange, which is a very strange background in that I have a bachelor's degree in physical science. I have a master's of business administration, and I have a system engineering Ph.D. But I've been doing system engineering all of my life. I started as a machinery officer in the Navy, and then did anti-submarine warfare. How do you find submarines? And then I started working at RCA Missiles and Defense on the Aegis combat system, and then worked on other systems throughout my career. So I've been in the systems engineering discipline and practice since college.
Okay. So it is possible to go straight from a bachelor's in some other engineering discipline and then get your master's.
That's actually the preferred path.
Okay.
That's actually the preferred path, which is great here at South because we have our 5 undergraduate disciplines and our 4 graduate disciplines. And then from those, some of those students go to a doctoral, as well as roughly a third of my students are actually working adults that have decided to go back to school and found out that we have this doctoral program in systems, and so they've decided to do that.
Okay. And so it sounds like systems engineering isn't just for engineers.
It's interesting.
In a way.
Again, another great question. If you're talking to a very purist engineer, they'll say, "Oh yeah, it's engineering, it's engineering." But if you look at the broader community of system engineers, in fact, there's an interesting research project going on for DoD. There's a lot of other disciplines that make very good system engineers. Astrophysicists make great system engineers because they don't deal with the down in the engineering weeds. They're used to worrying about how interplanetary bodies interact with one another, how they interface, how they affect. That's a system engineering trait. System engineering, and my wife actually calls system engineering an oxymoron. Engineers are taught to dive deep, and yet system engineers are taught to look broad and holistically. So there are a lot of engineers that are very content to go down and solve their ones and zeros and solve their algorithms and live down in the weeds. And then you have other people, other engineers that say, don't bother me with the details. I want to think about the big picture. I want to think about how this can be used. What is the vision of this product? Those tend to be the system engineers. So you have to be able to deal with uncertainty. Some engineers typically don't like uncertainty. They want a finite answer. System engineers are very comfortable with uncertainty for a very long time on projects as the project evolves.
Do you have a favorite class to teach here?
I like systems architecture, which is SE 606.
Mm-hmm.
Again, probably fits back to my roots. I like thinking about what is the architecture of the system. To me, that the architecture is the bones. It's the part the customer appreciates the least. Once the building is complete, they don't see the wall studs, they don't see the girders, they don't see the framing, they don't see the plumb, they don't see all that stuff that goes into building the building and the thought, but yet it's there. And every system, and frankly everything is a system except some of the most simple things, but every system has got an architecture. The question is whether the architecture was planned or accidental. In systems engineering, system architecture is taking that step back and looking at what are the requirements for the system of interest that you're about to design, who are the stakeholders, how is it going to be used, how does it fit into the environment, and then architecting a solution. There's a lot of ways to design a computer, but we have an architecture for, say, our laptops or our desktops today that has been proven over time that it satisfies requirements and is easy to use. So that was part of the architecture, and that was part of the thought that went into that system architecture. So I think that's the course I like the most. I enjoy dealing with the freshmen and freshman engineering also, being able to expand new minds and explore the possibilities. But I think I keep going back to the system architecture course.
Speaking of freshmen, what advice would you have for someone who's just starting out here at South, or an engineering student specifically? But
I think there's a number of things that you need to do. One is you need to learn to budget your time. You need to learn to manage your time. There are going to be things you have to give up. There's going to be new things you're going to do. But you have to keep track of the amount of time you spend in class, the amount of time you spend studying. You've got to stay healthy, exercise just to keep your brain fresh and nimble, keep the blood flowing. And you need to get involved with some of the engineering societies that we have, because there you're going to have upper class men, upper class women that become role models for you. You need to find those role models for both your upper class students as well as your faculty. Latch on to a couple faculty that really intrigue you, that inspire you, and get to know them, get to know their story, begin to seek their advice. As you get closer to graduation, you want to start thinking longer term. What is it you're going to do for the rest of your life? What is it you're going to do for the next 5 years? And start seeking advice there. So it's to do something that doesn't come natural to some engineers. A lot of us become engineers because we don't like people. Actually, as engineers, we need to become people persons. We need to become more involved with people and learn how to interact with them, because they're the ones that will mentor us into the right steps into the future.
what about for post-graduation? Do you have any advice for that area?
Find what you love and then do it. I actually sought out one of the executives at the Boeing company years ago, and I asked him, I said, how do you become an expert? How do you become a technical fellow, which is common in a lot of engineering companies? He said, all I can tell you is figure out what's going to be big 10 years from now, and then spend the next 10 years becoming an expert on it. And then he chuckled, he says, but that is the challenge, isn't it? Trying to figure out what's going to be the next big thing 10 years from now. And looking back on it now, he was absolutely correct. In my case, I guessed right. But more importantly, do what you love. Because if you do what you love, then going to work isn't a job, it's fun. And I love what I do now. I loved what I did in industry. So if you love what you do, it's much easier. It doesn't become a burden. You're not sitting on Tuesday thinking, my God, when does Friday come? You know, you look up and all of a sudden it's Friday.
What do you think makes specifically civil engineering, but engineering as a whole, the department here at South, what do you think makes it special or unique?
I moved down here from the Northeast. I was at Stevens Institute of Technology, right across the Hudson River from Midtown Manhattan, a place where a lot of people want to live. I wasn't one of them. What I liked about down here is the culture of the South. I love the city Mobile. What drew me to South itself is the faculty. I spent a day and a half interviewing with a lot of the different faculty in the different engineering disciplines. And I was impressed with faculty that could go anywhere in the country. The faculty could teach, or for those that are doing research, they could work in any university they wanted, and they chose to be here. And I think that there is a great faculty here, there are great leaders, and I decided I wanted to be part of it. It sounds cliche, it sounds trite, but to me it's also important that you work with people you like. And I really like their mindset, I like their enthusiasm, I like their focus on the students, and that was important to me.
Is there anything else that you would like to add in regards to civil engineering or systems engineering or South, or about yourself?
Go Navy, beat Army.
All right. Thank you very much, Dr. Cloutier.